In the last few lessons, we taught our program how to make decisions using if, else, if, and switch. That's powerful. But what if you need your program to perform an action many times? Imagine you're coding a game, and every time a player levels up, you need to print a banner 50 times that says, "Congratulations!" Would you manually type the printf statement 50 times? No, that's slow, boring, and prone to errors. Programmers never do repetitive tasks manually. We tell the computer to do it for us. We use loops. Welcome to Lesson 3.04. Today, we are learning the first type of loop in C, the for loop. A for loop is designed specifically for situations where you know exactly how many times you need to repeat a block of code. For example, I need to run this code 10 times, or I need to process items from index 0 to index 9. The for loop is often called the counted loop because it relies on a counter variable. This lesson will focus on dissecting the three essential parts of the for loop syntax, creating our first controlled, repetitive block of code. First, the three sections of the for loop. The for loop is arguably the most intimidating piece of syntax for C beginners because it packs three separate instructions into one line, separated by semicolons. The syntax looks like this. Let's break down the classic example, looping 10 times. Part 1. Initialization, integer I equals 0. This section runs only once at the very beginning of the loop. We use it to create and initialize the control variable, the counter. By convention, we often use I for index or iterator. In this case, we start our counter I at 0. Part 2. Condition, I is less than 10. This is the test. It is checked before every iteration. As long as this condition evaluates to true 1, the loop's code block will execute. As soon as this condition evaluates to false 0, the loop stops immediately. In this case, the loop will run as long as I is less than 10. Part 3. Update, I increases by 1. This section runs after the code block has executed, at the end of every iteration. We use it to modify the control variable. Here, I++, which is a shortcut for I equals I plus 1, increments our counter by 1. Second, the execution flow. Let's trace the loop above. Step 1, start. Action, create I, initialization. Assign 0 to I, condition, true 0 is less than 10. Output, loop iteration, 0, update. I increases by 1, I becomes 1. Step 2, action, check condition, true 1 is less than 10. Output, loop iteration, 1, update. I increases by 1, I becomes 2. Step 10, action, check condition, true, 9 is less than 10. Output, loop iteration, 9, update. I increases by 1, I becomes 10. Step 11, stop, action, check condition, false, 10 is less than 10, and the loop stops. The loop runs exactly 10 times, counting from 0 up to 9. Third, common variations. You don't always have to count up by 1. You can count down or skip numbers. Example A, counting down. This loop runs 5 times, counting 5, 4, 3, 2, 1. Example B, skipping numbers. This loop prints all even numbers from 0 to 20. Key takeaway. The power of the for loop is that you have total control over the start, the stop condition, and the step size all on a single line. The for loop is your best friend when you know the exact count needed, e.g., looping through all 10 items in a list, or running a simulation 1,000 times. But what about situations where you don't know how many times the loop should run? For example, keep asking the user for a password until they get it right. Keep reading data from a file until you reach the end. In these cases, the loop needs to run as long as a condition remains true, not based on a specific count. Click on the next video to learn the second essential looping mechanism. Lesson 3.05. Loops. While loop, the condition-controlled loop.